Okay, so this lecture is on the classification of matter, and we're starting a new section of Unit 1. Unit 1 is a big unit, and the first section we dealt with measurement, significant figures, accuracy, precision, all the beginnings of all of our labs are quantitative values. Now we're moving on to classifying matter, which is again, a mini unit within this large unit. And your first test is going to be on measurement, significant figures, conversions, and this matter and energy mini unit, which will take about a week to go through. But let's get started with the basics of this unit. And the basics are, how do we classify matter? And we classify matter, and again, matter is things that take up space. So we classify all things that take up space basically by two words. We have homogeneous and heterogeneous. Okay, now these two words describe all the fundamental things or classifications of each type of piece of matter. Okay, let's start with homogeneous. Now, homogeneous can be broken down into something called a substance. A substance is anything that is pure. Now, the word homo means the same. So homogeneous is the same throughout. And the same throughout, okay, is very, very important to understand. If it's the same throughout, that means it has the same properties, chemical and physical. And we're going to describe those differences too in this lesson. Okay, so we have a substance. Now, a substance can be broken down into two different types of substances. Well, the first one is a compound. Okay, a compound. Now, a compound is, of course, the same throughout. That's why it's homogeneous. And what makes a compound the same throughout is it's made up of the same type of molecules. Now, molecules, okay, are two or more, let's write this here, two or more different elements bonded. Now, when I say elements, I'm really talking about different types of atoms. Okay, and we know from the periodic table, which I'm going to bring up in a second, and let's actually go there now. So we're looking at the periodic table that I just opened up here, and in the periodic table of elements, and I've used the word elements, and I'm kind of using the word atoms alongside that. In the periodic table of the elements, we can see a bunch of different atoms, and they differ very importantly. All these symbols start with a capital letter, and that capital letter denotes a different type of elements. Okay, and they differ, and this is something we'll use for the rest of the year. They differ by the most important number on a periodic table, and that most important number, as I'm showing you right here, is called the atomic number. Okay, it makes each element differ, and so elements, okay, and I probably should have talked about this first, but elements differ by their proton numbers in their nucleus. We'll talk more about the particles inside, but very important that you look at potassium, K, it's got 19 protons. Calcium has 20. So the type of matter, the most simplest form of matter, okay, are elements. And these elements differ by fractions of just matter called protons in their nucleus. Those tiny differences on the microscopic scale make huge differences in the macroscopic. So these big numbers called atomic numbers, and you could see these listed for you, and this is the periodic table you'll see when you get your reference table. It's atomic number 6 is for carbon. Okay, only the element carbon has atomic number 6. Now I can break that down into something simpler. Elements are made up of the same type of atom. So if you are a carbon atom, you have 6 protons. The number of neutrons, electrons, and other things can be different, but to be a carbon atom, you have 6 protons. To be an element just means you have a bunch of carbon atoms. Okay? Now back to what a compound is. No compounds are listed. Compounds would have to be a bunch, at least two or more different types of elements chemically bonded. In fact, I should be more specific. Okay? Two or more different atoms chemically bonded. For instance, hydrogen, which is H, with atomic number 1, meaning the only atom in the entire universe that has one proton, okay, is hydrogen. And the only atom, okay, different type of matter altogether, lithium, and it only has 3 protons. But lithium and hydrogen can bond together, and when they do so, they make a compound when they bond together to make LiH. Okay, so that is a compound. So I'll give you that example when we go back. So when I say element, we're talking about a group with the same type of atoms, and atoms differ by proton number. So if I've got beryllium element, I've got a bunch of atoms with the same number of protons, which is 4. Kind of like if I had a helium balloon. Okay, let's go to helium all the way to the right here. We have helium. Maybe I can move it over. There's helium. And helium has 2 protons. So if I have a balloon of helium, we have the element helium in the balloon, but what we really have is a group of the same type of atoms with 2 protons. Okay, let's go back to my chart. Okay, so back to a compound. For instance, lithium hydride is a good example here, and let's put an EX here for an example. Okay, so lithium hydride is a compound. Notice 2 different elements. How do I know? 2 different capital letters. So we have different elements or atoms involved, and they have a unique arrangement, 1 lithium to 1 hydrogen, and that's called a chemical formula. So compounds have chemical formulas. Okay, so chemical formulas. Very important. Okay, and that chemical formula has a unique ratio. Now, something else to think about compounds, because they have a chemical formula, they have a unique property chemically and physically that's different from the individual atoms. So chemical formulas, but more importantly, compounds, okay, they lose their individual properties of their atoms to become a new property. So hydrogen loses its individual properties. Lithium loses its individuality and becomes new set of properties. So compounds differ, okay, because new properties result because a new structure results. Case in point, okay, an example over here, if I have the element sodium, okay, and we have the element chlorine, when they bond, they make sodium chloride. This is table salt. Notice 2 different capital letters. Okay. Now, sodium is explosive in water. Okay. And chlorine is a toxic gas. Okay. Mustard gas in World War I predominantly was chlorine, was the main ingredient. So we have a poisonous gas and we have an explosive compound. They come together, okay, and they make table salt. Now we know table salt doesn't explode in our mouth, and it certainly doesn't harm us because of the toxicity of the chlorine. So these have their individual properties, and they get new properties. Notice the chemical formula, 1 sodium per 1 chlorine, because that number per each of them also could change the properties. So sodium chloride, table salt, has 1 sodium per 1 chlorine. Okay, so let's get rid of that because we're going to need that area. Okay, so compounds, 2 or more different elements bonded in an exact ratio called a chemical formula. All right, very important. They're homogeneous because they're always made up of something called the same type of molecules. Okay, let's just put some different color around here. All right, let me give you another compound. Let's look at water. Okay, water actually looks like this, an oxygen bonding to 2 H's. We'll talk about the bent nature of water later in the year. But water, okay, is essentially H2O. 2 H's per 1 O. Notice the 2 here. So we have two H's. Notice the two different capitals, therefore the two different elements. Therefore, water is a compound. Now, water isn't arbitrarily H3O, H4O. It has exactly this arrangement or this ratio, two H's per one O, and the bonds between them. So water has a unique chemical arrangement, and because of that chemical arrangement, it has a new set of properties. Hydrogen and oxygen together are explosive, as I'll show later in the year. But water is not explosive, okay, in this state. The individual elements lose their properties and gain new ones, okay? So that's another example. But if I say I have the compound water, what does that really mean? That really means I have a bunch of the same type of molecules. We really don't talk about, hey, one molecule, okay, in a flask. If I have water in a flask, we have a compound. So a compound is a group of the same type of molecules that exhibit the same ratio. So this is a compound. What makes a compound homogeneous? Well, look very carefully. What does it have? It has the same molecules. And because the molecules, because of their arrangement and losing their properties to gain new ones, we have individual properties. So that's how a compound works. Now, the thing with a compound, though, if you notice, because of its arrangement of different atoms, or we'll say elements if they're the same type, they can be broken down. This molecule can be broken down into hydrogen atoms and oxygen atoms. So a compound isn't the most simplest structure. What is? You got it, the individual atoms. Okay, so if you look at compound, I'm going to scroll down in this sheet here. Compounds can be broken down further, and they're broken down. I'm not feeling this green. Okay, they can be broken down into elements. Now, elements are the group of the same type of atoms, and elements cannot be broken down into anything simpler. Which means if I write helium, which was one of our elements, okay, in the periodic table that I just showed you, nothing can break helium down because it's already atoms with, you guessed it, 4 protons. I'm sorry, 2 protons, because helium, if you look in the periodic table, has a 4 above and a 2. That big 2 means 2 protons, and we'll talk more about those differences in atomic structure. But if I was to have sodium chloride, could I break sodium chloride down? Sure, you can break it down. Different capitals, different elements, this can be broken down into the elemental forms of sodium and chlorine. Okay, so compounds can be broken down into elements. Elements cannot. Let's go back up the sheet here. Okay, and let's get rid of this. Okay, now, well, if a compound is homogeneous, what else can be homogeneous? Well, you probably guessed it, elements. And an element, as defined already, is a group, okay, group of the same type of what? Atom. And atoms differ by their proton number, which is their atomic number. Okay? And they cannot be broken into anything simpler. Element is the most simplest form of matter that retains individual properties, because elements can be broken down into protons, neutrons, and electrons, which are part of an atom. And we know that protons and electrons can be broken down into quarks and gluons and leptons and all different types of smaller particles that atom crushers, okay, or splitters have found. But all quarks, okay, are the same. Okay, protons are the same. Electrons are the same. They have the same properties. what makes an atom unique is that the grouping of protons with its electrons and neutrons makes a whole set of new individual properties. So the most simplest form of matter that cannot be broken down into anything else and still retain these individual properties is an element, and that's what we're going to stand by in this course. Okay. All right, moving on, let's change colors because I'm getting tired of the magenta. I'm going to go with the black. Okay. We also have one more homogeneous, and notice it's superseding or getting away from the substance. Okay. And that, my friend, is a mixture. A mixture is not a substance. Substance is something that is pure, okay, and I should have said before, is made of one type of thing. Pure, and I should say one quantity or one quantity. For instance, in a molecule, you're made up of one type of molecule if you're a compound with an exact chemical formula. If you're an element, you're made up of one type of atom, like helium or hydrogen. Okay? These guys are made up of one type of atom that differs by their proton numbers. I'll talk about some that bond to themselves later. Okay? In any case, a mixture is not made of one quantity, it's two or more. Now you may say, Mr. Grotzky, it sounds like a compound. No. Compounds are chemically bonded. Chemical formula means there's a chemical change. Chemical change. There was a bond made. Once bonds are made, chemical formulas are made. Here, okay, mixtures are made by a physical process. We're not changing formulas. So this is very important because it's a physical process. The mixture, okay, is made physically and broken down physically, but more important, a mixture, and this is important, retains its individual properties. Case in point, all right, if I was to have a beaker, and this beaker had water in it, okay, and if I had sand at the bottom, okay, this is a mixture. The water's still going to boil at 100. The sand will still melt into glass at a certain temperature. I could separate this mixture by putting a screen through. Okay, there's no chemical bonding between the two. So the water and the sand retain their individual properties. Whereas in a compound, very different. Okay, they do not. All right. Now, mixtures can be homogeneous. What type of mixture is homogeneous? Okay, very simply. The homogeneous mixture is one where there is dissolving. Okay, so dissolving is your friend here. So if I have sodium chloride dissolved in water, we say it's aqueous. The first drop is the same as the last. The aqueous tells me it's dissolved in water, and we have something very important called a solution. Solutions are homogeneous mixtures. The first drop is the same as the last because they're equally mixed. But they can be separated physically. I can boil off the water. Boiling off the water is a physical separation because water in the gas phase, okay, and water in the liquid phase have the same chemical formula. We're not changing the arrangement in a compound. Okay, so very important. Another mixture is homogeneous. Okay, could be, well, we'll just keep with solutions. Those are the best examples. Okay, I'm almost done here. I have to get ready because my other class is coming. But very quickly, the only thing that's heterogeneous, okay, is a mixture. That's not the same throughout. Not the same. So you can have seeds, or in the case of the beaker of what? Water and sand, not dissolving. Okay, you can have a salad, the tomatoes, the lettuce, and all components of a salad, the seeds in a watermelon, okay, heterogeneous, the kids in a classroom. Most mixtures are heterogeneous, but if they're evenly mixed, okay, they're homogeneous, kind of like mixing bowl if you're making a cake, okay. Notice the only thing that is heterogeneous is a mixture, but careful, mixtures can be heterogeneous or homogeneous. In the special case that they're evenly mixed, they're solutions. Okay, we'll stop here for now.